All right, thank you very much for having me discussing this really interesting paper. This paper uncovers a few new factors for crypto assets. Basically, this is a 5-factor model, including the market factor, size, value, momentum factor for large cap cryptos, as well as the most novel factor, which is called the network factor, which I'll explain a bit more later. This model substantially outperforms existing models in explaining the cross-section of crypto returns. Now, in terms of the network factor, one key measure is the growth in active wallets on the blockchain. This factor is motivated by the earlier paper by Chong, Li, and Wang. They show that user adoption is a really important factor increasing crypto value. And also the authors spent a lot of time classifying cryptos into general payment, platform, product, and security tokens. And to my knowledge, this is really the first attempt in classifying cryptos into those 4 very useful different categories. And they use the international 5-factor model, and which actually works best for those 4 samples. And this suggests that there is some segment within the crypto market. Now, from here, you can see that this is a 25 size value portfolio sort for the 4th sample. And if you compare the 5-factor model here in the red box versus the 3-factor model in Liu Tavinsky and Wu JF forthcoming paper, you see that the 5-factor model does improve the time series fit along many dimensions, right? For instance, the average absolute alpha is reduced to 2.8% per week. And the average R squares is actually much higher, as well as a much smaller GRS stat. Now, one thing seems that the constraint R squares is lower. I cannot really understand why that's the case, but at least along most of the key dimensions, the 5-factor model works much better than the existing models, including the Liu and the co-authors paper. Now, if you look at the 15 core sample portfolios, that's even better, right? This sample includes the more than 600 cryptos with network data available. These are typically large cap cryptos, but the sample also includes some smaller ones. You see that now the average alpha reduced to only 0.5% per week. I mean, to my knowledge, this is really the best model that can have such low average alpha. And also, in terms of average R squares, constrained R squares, they're bigger than the standard 3-factor model. And also the GIS statistic is lower. Now, I think it'll be useful to provide some discussion on what each factor may capture. I think, as Will mentioned, this is an early stage paper, so they are not getting there yet. But I think giving the reader some intuition of what each factor might capture would be useful. For instance, in the Liu and co-author paper, they kind of suggest that the size factor is a proxy for liquidity premium as well as convenience yield, in the sense that people like to hold large cryptos like Bitcoin in order to do transactions. So I wonder whether the authors agree with this kind of interpretation, or is there any alternative explanation for that factor? And also, as Will mentioned, in contrast to equity, the momentum effect seems to only work for large cap cryptos. And I wonder why that's the case. Now, Liu and co-authors think this is consistent with investors' overreaction in the Pen and Xiong paper, but I wonder whether there's any more direct, explanation behind this effect. The value factor, which is really the negative of the past year return, that is consistent with the observation in equities. There were many different explanations for value in equities, including risk-based ones and behavioral ones. But I think the crypto settings, so it seems like the crypto setting is quite different. For instance, how do we measure value, right? In the traditional sense, in the sense of market over book, can we do a similar measurement like that, which is not very clear. So the network factor clearly works. If you look at the single sort, right? This is a single sort of the growth in active wallets from low to high. You see that the fifth percentile clearly works much better than the first percentile in terms of returns. And Liu and the co-authors actually has a new paper that supports this key result. They also find that the number of new addresses would positively predict crypto returns. So this seems to be very robust. But if you look at, if you compare the 5-factor model here at the bottom with the 4-factor model here, without including the network factor, looks like the 5-factor model does not reduce the alpha that much. It reduced alpha by 0.1 percentage point per week, and the R squares, is not increased too much, although the constrained R square is much bigger than the 4-factor model. So I wonder why that's the case, right? Given network factors is a such useful and robust factor, as you can see over here. Now, when I was looking at the spanning regression of regressing the network factor on the 4 factors over here, the market size, value, and momentum for large caps, the T statistic is only about 1.8. So I wonder whether this suggests that adding the network factor to the 4-factor over here might not reliably improve model performance too much. But when I look at the correlation table, I see that the correlation between network and those 3 factors over here is pretty small. So this is pretty comforting. But I think it'd be useful to also show the correlation between the network factor as well as the momentum for the large cap. So see whether that's small or large. If this is also small, then I think we have more confidence in the contribution of the network factor in the 5-factor model. But on the other hand, if you look at the 3-factor model, this actually the 3-factor model already performs really well. So if you look at the core sample, right, these are the large cap cryptos in general, you see that the 3-factor model here already has a very low average alpha, already has a small GRS statistic. And also, if you look at the 4 sample, let me go back to 4 sample. You see that in the 4 sample, the 3-factor model works almost as well as the 5-factor model. So I wonder, I feel like this shows that the value factor is really important, but this would also maybe cause for more investigation into the network factor. As I mentioned before, the model works really well for the core sample, which includes mostly large cap cryptos. But for the smaller sample, for the 4 sample, it in general works worse. For instance, the average alpha is about 0.8% per week, which is pretty large for cryptos. So I think it will be interesting to find out what are the reasons behind such a difference. One reason might be that the small cap cryptos are more prone to pump and dump schemes or rug pulls, which are usually do not happen to large cap cryptos. And also, one observation here is the network factor is constructed for the core sample only. So I guess by construction, this one might work a little less well for the full sample. And then one really interesting fact I see in the paper is the authors were trying to come up with the value factors that are kind of similar to the traditional factors in the equity space, which include the user to market ratios, address to market ratios, or even the trading volume to market ratios. But those factors do not work as well as the very simple the negative of the past 1 year return as the value factor. So I wonder, what is going on here? Is this because there were severe measurement errors in measuring assets, right? Measuring assets of crypto platforms in general is very hard, but is there any other reasons why those more interesting value factors do not work well here? I guess I'm running out of time, so let me quickly just mention a couple of things. I think short sale constraints might be something people will be asking about because still today it's pretty costly to short cryptos, especially the smaller ones. However, Israel and the co-authors, they found that at least for value and the momentum factors, the long and the short size roughly contribute equally to the anomalies. And they also find that the long-only portfolios of value and momentum still produce abnormal returns. So I wonder whether the authors could do something like that here to kind of show people that short sale constraints is really not a problem. And maybe another thing to do is to look at subsample, the period after December 2017 when the Bitcoin futures were launched, after which shorting cryptos will be much easier. And also maybe looking at post 2020, I know it's a very short sample, but after 2020, crypto lending became much easier to do. And I wonder whether including some standard macro risk factors like term spread, default spread, or GDP growth could reduce the average alpha for the full sample. So to summarize, this is really an exciting paper that uncovers new and novel factors for crypto assets. In my opinion, this is really the best paper in this field. And the 5-factor model substantially outperforms existing models in explaining the cross-section of crypto returns. I think it'd be useful for the reader to have some discussions on what each factor may capture. And also it might be useful to think a bit more about why the model works much better for the core sample, which includes mostly large cap cryptos, and whether additional